Okay, everyone. So today we're going to be discussing programming for FTC. This will be the start of our programming course that we will have in place of our meetings due to the current health concerns. Um, but this will be a good way to get points for completion of the course and its projects. I will link a Google form for participation in the course, and when you fill that out, you will be notified and emailed in the future with a link to an established project with a due date, and it should be completed, along with the lessons. The lessons will not tell you exactly how to do the projects, but they will help a little bit. So the first thing you're going to want to do is download Git. Okay, download Git, and you're gonna want to make a Git bash. Okay, here there's a good tutorial in the link, the description below. Read that README that I have there. It'll tell you exactly what to do for Git. You're just gonna want to click here, click this, and then make a Git bash. Okay, so here is the Git bash, right? You're just gonna want to type git clone and then insert that link in there, okay? And then enter that in, okay? So once you do that, then you're gonna want to open up the project in Android Studio, okay? So here we have the project in Android Studio. It's a completely blank one here, okay? So if you clone, so what you're gonna want to do is actually you don't want to just clone it directly. That's my mistake. You actually want to make a fork here. So you're gonna click right here where it says fork. You're gonna click on that and you're gonna fork it. Okay? Fork it to your own account. And then you're gonna do the same thing there, what you do here, okay? So that way you can add it to your own account. Alternatively, you can use the one here for mine. You'll see my repository here, right here. You can go to my account and you can fork this one here, set mine as the upstream. Okay. So now here's what we're going to do. First thing you're going to want to do is you're going to go online to FTClib. Okay. Now FTClib is a library that is the library for which I'm the lead developer. Okay. What FTClib does is it makes your programming a lot easier. All right. So I'll teach you basic concepts for FTC programming using FTClib. Okay. So what you're gonna do is once you have your Android Studio project ready, you're gonna go into Android Studio. You're gonna go into your build.com and .gradle. You're going to put right here in your repositories place right there, JCenter. And here you're gonna change version 1.8. Version 1.7 is what it was originally, and you're gonna change that to 1.8. Okay, you're gonna put JCenter right there in that repositories place. Next thing is you're going to go to the build.gradle and your team code module right here. And underneath your apply from, you're going to want to put dependencies, okay, implementation, and you're going to put com.arc robotics ftclib 2.0.11, and then you're going to sync your Gradle. And so sometimes you're going to get something like this, right? So that means that you need to go back to your common Gradle, right? And you actually need to change your minimum SDK version to 24 because we use more advanced features. And all of this is actually told to you right here in that ftclib menu right here. Okay? All of that stuff is here. And so there we go. Now we have a successful build. So the first thing we're going to want to do is you're going to make a new package. Okay? You're going to call that hardware. Okay? And so here I'm going to teach you how to make a custom motor. So you're going to want to right here, as you can see right here, you're going to want to make a new motor. Let's call it Yellow Jacket 435. Okay, you're going to make it a class, and the super class you're going to put no, for the interface you're going to put motor. Okay, so now you're going to do Alt Enter, right? And you're going to implement those methods. Okay, so these are the methods that you need to override. So the first one we have is set. So for our Yellow Jacket, we want to make a DC motor object here, right? And then we're going to call it my motor, or we can just call it m underscore motor for for my motor, right? Naming conventions, of course. And we're going to, for setting the speed, we're going to do m. Well, first of all, we kind of need a constructor, don't we? So we're going to do public Yellow Jacket, and then we're going to do, let's just have it import the hardware map. And the name of the object. Okay, and then for our motor, we're gonna make it by doing hmap.get like that. Okay, and we're gonna make this private. All right, and then for set, we're gonna do mmotor.set power speed. Okay, getting, we're gonna do get power. Okay, now let's also do our own method here. Right, so let's set RPM or set speed, and then we'll define that as setting the speed in terms of rotations per minute. Yeah. And then you have your parameter, speed, which represents the speed in RPM. Okay. Next thing you're gonna do is for set speed, you're gonna do set, okay, and then here in your constructor, you're going to want to add a double get RPM. Actually, this is a 435 RPM motor, right? So we actually already know the RPM. We don't need to pass it in. So we already know that the speed is just a percentage of the maximum rotation. So we're just going to divide by 435, just like that. And then PID right is just set output. And then this can be changed so that it actually does a PID right. So you can actually import a PID controller. Okay. And then you can put that right there. You're going to do output, and then you're going to do get right there. Oh, right, can't do that in volts. Terms of output speed. And then stop motor, we want to just set 0. Common naming concepts. For disable, we're going to want to close it, close the device. For get inverted, so for inverted, right, we're going to return if we're actually going to make another constructor for overloading. Just like that. We've reversed the motor. And we've overloaded the constructor. Just like that. Okay? So now when we pass this in, we get a motor that is set default forward direction, otherwise it's reversed. Alright, there we go. And now set inverted, we can actually just do that here. Boom. So now here, wait, hold on before I do that. There. Alternatively, you can write this, which is actually what I recommend doing. You got your ternary operator right there. Ternaries. There you go. And just like that, we have overwritten that motor interface and now created our own custom hardware. Okay, so now we're going to create a new package. Oh, whoops. We're going to create a new package. Our new package name is going to be, let's call it op modes. I'll post a link to this repository in the description below, as well as the original Skystone one, so it's your choice which one you want to fork. Oh, and then for you guys, I want you guys to create a new package, right? I want you guys to label that one project submissions with an underscore like that. Okay, so right there. Now for op modes, let's make a new Java class, and let's call it basic op mode. And our superclass is going to be op mode. Okay, right there. Add it to Git, implement the methods, and there you go. At the top, I want you to put my first op mode. I know it might not be the first op mode for some of you, but just put that there. I'm just going to put that there anyways. Right, and then I'm going to put right here in Java docs, I'm going to say alright. So, first thing we're going to do is we're going to annotate this as teleop. We're going to put the name of it right there. And let's call it simple mechanism bot. Okay. This annotation tells the driver station that yes, this is a teleop, not an autonomous. Right? That way it actually shows up in your driver station. So first thing we want to do here is we want to create our mechanism drive. Okay. Naming conventions. Now let's make our yellow jackets. We have M. There we go. Just like that. String name. We don't want any of these to be inverted because the mechanism drive does it for you. And even if you do invert it, then it'll fix it for you as well. But we don't need to invert them, so no need in doing that. Let's call this one FL. that one FR. Standard naming conventions, people. Let's keep them together. Make sure you're using the same ones as everyone else so that your code is readable and understandable and intelligible, of course, so that even someone who's slightly illiterate can read it. That's the point of the code. Right, and so if we go back to documentation and we take a look at the mechanism drive in ftclib, whoops, you have auto invert. Okay, and what this one will do is it will auto invert it for you, right? So it automatically sets the right side to invert it. This one will do it false in case it's already inverted. Okay, so it really does do a lot of things for you. So then you're going to want to put them in this order, because if we go here, right, right, you'll see this, right? Right, so here you have this. So my motors, the motors are in order of front left, front right, back right, and don't input in any other order. Okay, what it specifies right there. So that's what we're going to do: front left, front right, back left, back right. Okay, now we have our drive. And let's get our IMU. This will allow for field-centric driving. Let's go to our documentation for the IMU so that you can find that in hardware right here. And that is, you just put in the hardware map and the IMU name, which should generally be just IMU. So I would recommend just putting in the hardware map and then leaving it alone. And then it should do it for you if it's vertically oriented. So that means that your Rev IMU, your Rev Hub, is vertically oriented on your robot. And then in your loop, you're going to do mDrive dot drive field centric, right? We want to do field centric. We don't want to square inputs. So here you have two things you can do. Okay. You can do x speed, y speed, turn speed, gyro angle, or x speed, y speed, turn speed, gyro angle, and then square inputs, which is a boolean. which generally you would just put false. You would just put true for if you want that, and then don't put anything if you want it to be false. You don't even need to put it in. So we got to do x speed. So that's going to be gamepad1 dot left stick x left stick y, because the left stick is going to be your drive stick, and then your right stick x is going to be your turn, and then your gyro angle is going to be your IMU dot get heading. Right? But then you'll probably want to turn that into radians. So you're just going to do math.2 radians around that right there. Easier than having to set up the parameters for it. That is an alternative though. You can just set the parameters for it, and then that's it. You're done. That is an entire Mecanum drivetrain right there. Or you with custom motors, custom things you can do. We can even do, instead of doing this, we can do other things, but this is what we will do. So that's it for this video, and I'll see you in the next course session.